Hello there, this is a video about analysing the motion of a ball for math studies. A ball is thrown from the top of a building. Its height in meters above the ground t seconds after being thrown is given by h of t is equal to 160 plus 20t minus 5t squared. Find equations for the velocity and the acceleration of the ball and interpret their meaning. Use your GDC to find the following: the time and the maximum height of the ball, and the time when the ball hits the ground again. So we got this function h of t is 160 plus 20t minus 5t squared. So this represents the distance height above the ground, so it's a distance thing. Now, velocity is the rate of change of displacement with time. So for velocity, you have to actually differentiate the function, because v will be dh over dt, which we can also write as h dashed of t. So if v is dh by dt, then if we differentiate 160 we get nothing. If we differentiate 20t we get 20, and if we differentiate 5t squared we get minus 2 times 5, which is minus 10 t, and reduce the power by 1 we get t to the 1. Now, the interesting thing is what happens when this is equal to 0, because what you've got to imagine, when you throw a ball up, it's going to get to a certain height and it's going to come back down again. So if we put v is equal to 0, i.e. no velocity, then if we put 20t minus 10t is equal to 0, we're going to get that 20 is equal to 10t and t is equal to 2 seconds. So at 2 seconds, the ball will get to the maximum height. If t is less than 2 seconds, the velocity will be positive, because when you start throwing the ball upwards, it goes upwards something like this. At t is equal to 2, it's its maximum height, so the ball will go up like this and get to a maximum height. And if t is less than 2, then the ball will go back down again. So the velocity will be negative. Alright, and the velocity you can get from the gradient of this function. Now, what happens if we differentiate velocity again? Well, if you differentiate velocity again, you get what's known as acceleration. So acceleration is differentiating velocity. Remember, this is velocity again, and we get the idea of the second derivative. And this is written like d squared t dt squared. This is called the second derivative. In function notation, we write that as a as double dash of t. So if we differentiate this again, we're going to get nothing from the 20, but we're going to get minus 10. So we actually get a constant for the acceleration. Now, you might recognize this as the acceleration is a constant minus 10 meters per second squared. This is known as the acceleration due to gravity, because what happens, the ball goes up, it's affected by gravity, it gets to a maximum height and then goes back down again and to hit the ground. Right, so we've now analysed the motion of the ball, which been modelled by this function. We can actually now look at it using the GDC. So if we go to the GDC and select a graphing mode, and we put it in 160, we can't put it in terms of t, but we'll put it in terms of x instead, plus 20x minus 5x squared. Press enter. Okay, we're only really going to be interested in the positive part of this curve here, and we're not interested in the negative part here. We're not interested here because we can't actually go back in time, and we're not interested in going under the earth, because this line here represents the ground, and we need to find where it starts. So to do that on the GDC, we need to set an appropriate view window. So menu, window zoom, window settings, and just change that to a 0. Press OK, and now press menu, window zoom again, and zoom fit. So what that does, that will fit. If I set my x-axis, it will fit the y-axis. Now, So the points I'm interested in are this point here, this point here. This is where the height of the building is. This is the maximum height the ball will reach, and this is the point where the ball will hit the ground again. Right, to find this one here, I could do menu, trace, graph trace, and then if I put in 0, I'll select the y-axis and press enter. Now what happens is it's actually moved the view window a little bit. So to get around that again, if I just go back to menu, escape first, press enter again and then escape. So we get a height of 160. And to get back the same view window before, we go to menu, window zoom, and just press zoom fit. Again, it'll go back. Menu, window zoom, we'll just set the settings again to 0 to 10. A bit unfortunate the calculator changed these, but there we go. And press OK, and then do a zoom fit. Menu, window, zoom fit, and we've gone back to the same graph. Right, to find the maximum height, we do menu, analyze the graph, and maximum. Go to the left of it, go to the right, and we get the at 180. To find this one here, where it hits the ground again, we're going to go menu, analyze the graph, and this time we want to 0. We go to the left, and to the right of it is going to give me 0. So after 8 seconds it hit the ground again. And after 2 seconds it gives the maximum height. Right, we should draw a graph of that, but we now put the graph in terms of its original terms, t and h of t. Write down the name of the function. Mark on these points of interest. So this one's going to be 160. That's the height of the building. This is the maximum height of the ball. It's 180 meters at 2 seconds. And this is where the ball hits the ground again at 8 seconds. So the height of the building, the maximum height, and the ball hits the ground. Notice here, like we just said before, the velocity is positive, so the gradient is positive. Okay, so the gradient is the velocity in this case. So from here to here it is positive. At this particular point it's 0, and after this point the gradient is negative. Now, another important fact is between here and 2, 0 and 2, the function is what's known as increasing, i.e. it's getting bigger, the gradient is positive, and if the gradient is negative, then the function is said to be decreasing. To answer the 2 questions, part A, just one extra thing, the acceleration on this is acting downwards at minus 10 meters per second squared, which makes the ball get to a certain height and then come back down. The time and the maximum height of the ball are given by this here. The time is 2 seconds and the maximum height is 180 meters. And B, the time when the ball hits the ground, again, will be this point here at 8 seconds. So T will be equal to 8 seconds. So this has been a video to show you how to analyze the motion of throwing a ball off the top of a building, throwing it upwards until it meets the maximum height and then come back down to the ground again. I hope you understood, and I thank you very much for watching.